Hi, welcome to section 6.3. Today we're going to be proving parallelograms. In other words, how do I know a quadrilateral is a parallelogram? And so, just like last time, we could write lots of different theorems, but instead we're going to combine it all into one chart, which again, you should probably know in the near future, like on a test or a quiz. So, the first thing you could do is you could show both pairs of opposite sides congruent. You could show both pairs of opposite sides parallel. You could show both pairs of opposite angles congruent. You could show that diagonals bisect each other. So far, we've got 3 O's and a D of our properties, right? So 3 O's and a D, and then our last one really isn't represented in our properties, but you could show one pair of sides, and let's say that's one pair of opposite sides, parallel and congruent. So in other words, if we have our parallelogram, you got to show that they're congruent and parallel. Just one pair, the same pair, congruent and parallel. So using what we know from this, we're going to play always, sometimes, never. So let's start with the first one. The diagonals of a quadrilateral bisect each other. The correct answer is sometimes, because not all four-sided figures have diagonals that bisect each other. If it said parallelogram, then our answer would be always. Number 2, the measures of two angles of a quadrilateral are equal, then the quadrilateral is sometimes a parallelogram, because it just says two angles. And remember, for it to be a parallelogram, we got to have both pairs of opposite sides. Not opposite sides, opposite angles congruent. Number 3, if one pair of opposite sides of a quadrilateral is congruent and parallel, then the quadrilateral is always a parallelogram. That was that last statement we wrote down in our chart. And here's the important information here. One pair and congruent and parallel. Alright, number 4, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is always a parallelogram. That's one of our O's. And then number 5, to prove a quadrilateral is a parallelogram, it is blank enough to show that one pair of opposite sides is parallel. It's never enough. You got to show that one pair of sides is opposite sides is parallelogram and congruent, or both pairs are parallel. Okay, so that's always, sometimes, never. Let's take a look at whether or not these shapes are parallelograms, and we're going to be asked why or why not. So let's take a look at this one. I've got sides. I've got one pair of opposite sides congruent and two pairs of opposite sides congruent. So, yes, it is a parallelogram, and that's because both pairs of opposite sides congruent, therefore it's a parallelogram. Alright, let's take a look at number 2. I've got a pair of opposite sides that are congruent and they also happen to be parallel. So, since they are congruent and parallel, we say yes. One pair of opposite sides are parallel and congruent. Therefore, it's a parallelogram. Alright, the third one. I've got one diagonal that's bisected and one pair of opposite sides that are congruent. That's not enough information, so I'm going to have to say no. Alright, number 4. Look at my diagonals. They're being bisected, so yes, the diagonals bisect each other. Therefore, it's a parallelogram. Alright, number 5. I have one pair of opposite sides that are congruent. I don't know anything about A and C. And sorry, they're not opposite sides, they're opposite angles again, sorry. So no, I don't know if it's a parallelogram. Well, let's take a look at this one. I've got 3 angles that are labeled. And remember, I've got 360 degrees in a quadrilateral, so 110 plus 70 plus 70, that's 140. So 0, 5, 2. 360 minus 250 is 110. So if that's 110, I've got both pairs of opposite sides. Not sides. I'm not sure why I'm messing that up today. Both pairs of opposite angles congruent. Therefore, it's a parallelogram. Alright, what I'd like you to do right now is go ahead and pause this and do 7, 8, 9 on your own. Alright, let's take a look at number 7. For number 7, the answer is yes, and it's because both pairs of opposite sides are parallel. Now you must be thinking to yourself, where did you find the other side? Well, I've got 2 lines perpendicular to the same line, so therefore these guys are parallel. On 8, I've got alternate interior angles here, so this makes these 2 sides parallel, but the other sides are congruent, so that's not enough information. That's a no. And the last one. These 2 pairs of alternate interior angles make these 2 lines parallel, these 2 sides, and these 2 pairs of alternate interior angles make these 2 sides parallel. So, since I have both pairs of opposite sides are parallel, it is a parallelogram. Alright, hopefully you took the time to write down any questions you had in the margins. Go ahead and head on over to MathXL.